Yes.
Right. So I'm discussing here enthalpy of ionization. Here I have an atom A, and after loss of electron I'm getting one electron out. I'm knocking out one electron. So certain amount of energy is required. That energy requirement is called the enthalpy of ionization. Delta IH is a symbol, I for enthalpy, ionization. Certain joules of energy is required, right? So write down, it is defined as the amount of energy
Yes, sir.
required to eject out the most loosely bound electron from outermost shell of an isolated gaseous atom. Isolated gaseous atom. Isolated gaseous atom.
Yes, sir.
So here I have an isolated gaseous atom, and from that isolated gaseous atom we are removing one electron. So how much energy is required? That is called as enthalpy of ionization.
Ionization. Yes.
It means here we have a nucleus and outside we have number of shells, and this is the outermost electron that is to be ejected out, right? And for
Yes.
that we are providing some energy, and this energy is going to eject out electron. So electron is negatively charged and the nucleus is positively charged. There is some force of attraction between the two. If a strong force of attraction, the ejection become difficult. Yes or no?
Yes, sir.
Right. So write down factors affecting enthalpy of ionization. Factors affecting enthalpy of ionization. Number one. Number one is size of an atom. See, if the number of shells increases, the size will increase. Yes or no?
Yes, sir.
Distance from the nucleus will increase.
Yes, sir.
And between the electron and the nucleus, there is a electrostatic force of attraction. This is known as the Coulomb's law. Between the positive charge and the negative charge, there is some force of attraction, and that
Sir,
force is
what
called,
is Coulomb's law?
yeah, there is a force of attraction between the negatively charged electron and the positively charged nucleus. This force of attraction is called as the electrostatic force of attraction.
Okay.
Okay, electrostatic force of attraction. And this force of attraction is governed by law known as the Coulomb's law. This law states that force of attraction between two oppositely charged particles, that is the positive charge nucleus and electron, directly proportional to charge of the nucleus and the charge of the electron, and inversely proportional to the square of the distance between the two.
Okay, sir. Can repeat it as directly proportional to?
Charge
Yes.
on the nucleus and charge on the electron.
Okay.
Charge on the nucleus and charge of electron. Right?
Yes.
It means if the R increases here, means the R means distance between the nucleus and the electron increases here. If the R increases, the attraction will decrease.
Yes, sir.
If the attraction decreases, what will happen?
The charge will
The
decrease.
removal will become difficult, will become easy. The
Okay.
electrons are less tightly held by the nucleus. It means
Okay.
if the enthalpy of ionization is inversely proportional to the size of an atom. If the size increases, the enthalpy of ionization will be less.
So this F is enthalpy.
Now, F is the force of attraction between the electron and nucleus.
Okay.
Right. F is the force of attraction between the electron and the nucleus. Right. Understood?
Yes, sir.
Now, second factor is the charge on the nucleus, or I can say nuclear charge. Say more the nuclear charge, then more the force of attraction. See Q1 charge of nucleus, charge of electron upon R
Yes.
square. If
Yes,
attraction is
sir.
more, it will become difficult to remove electron.
Yes, sir.
Right. So I can say enthalpy of ionization is directly proportional to the nuclear charge. Is directly proportional to nuclear charge.
Yes.
Am I clear?
Yes, sir.
Third factor that influences the enthalpy of ionization is the electronic configuration. Electronic configuration. Right, on the half filled and completely filled electronic configurations are more stable. Half filled and completely filled electronic configuration are more stable than incompletely filled electronic configuration.
Yes,
Than
sir.
incompletely filled electronic configuration. Right? So,
Mm-hmm.
maximum energy is required to remove electron from completely filled, less from the half filled, and least from the incompletely filled.
Yes.
Am I clear?
Yes, sir. The least from,
Incompletely filled.
sir, what is in,
I
can
tell
you
you.
give an
I'll
example?
give you example. Nitrogen, atomic number 7, right?
Yes.
In case of nitrogen, if I check here electronic configuration, it is a 1s2, it is 2s2, and then 2p3. This you can see this p subshell is half filled.
Yes, sir.
But if I talk about oxygen, even though it has a higher nuclear charge, but if you see the electronic configuration, you can see it's the 2p4 and it is not half filled, it is not completely filled. It is incompletely filled.
Okay. Okay.
So if you compare here the nitrogen and oxygen, then the enthalpy of ionization for the nitrogen will be more than that of the oxygen.
Yes, sir.
Any doubt till now?
No, sir.
Right?
Yes, sir.
Understood?
Yes, sir.
Any doubt till now?
No, sir. No.
No. Second is the third in the penetration of orbitals. For example, we have now 4s subshell, 4p subshell, 4d subshell, and 4f subshell, right? Which
Yes,
is
sir.
more which is more closer to the nucleus?
Four as.
4s. It means to remove electron from the 4s, we require more energy as compared to 4p. and this is the
Yes, sir.
decreasing order of energy.
Yes.
Any doubt?
No, sir.
No doubt. Next is the screening effect. Let's talk about what is the screening effect. What is this screening effect? Here I have a nucleus, and these are the shells of the inner energy level, and this is the outer electron here. In the first shell, I have 2 electrons. In the second shell, I have 8 electrons, and so on. The inner electrons are there. So what will happen? The nuclear charge will not be able to reach out effectively to attract the outermost electron. It means here we have an actual nuclear charge, Z actual. But what is experienced by the outermost electron is an effective nuclear charge. And
So
this
can you
effective
repeat?
nuclear charge is less than the actual nuclear charge because the inner electron shells have stopped the nuclear charge reaching out. And
So
this is
can you
called
tell
as a
this
screening
again?
effect. Yes, Karman.
Yes, sir. Can you tell this again?
Yeah, sure. Karman, just like this, here we have a nucleus. These are the inner shell electrons, right? And this is the outer electron here. Nuclear charge that is actually here, Z actual, is not reaching out here to attract the electron because the inner electrons are stopping the nuclear charge. They do not allow the
Okay.
nuclear charge to reach out effectively. They are stopped in between, they are screened in between. So the effective nuclear charge is less than the actual nuclear charge. Due to the inner electrons, they are stopping the nuclear charge from reaching out, and this is called as the screening effect. Am I clear?
Okay, sir.
Any doubt till now?
No, sir.
Am I clear?
Yes, sir.
Now, next write down variation of enthalpy of ionization down the group. Variation of enthalpy of ionization down the group. See, as you go down the group, what will happen to number of shells? Can you tell me?
Number of shells will increase.
Increase. If the number of shells will increase, the nucleus and the electron distance will increase.
Yes, sir.
If the distance increases, the force of attraction will decrease.
Yes, sir.
If the attraction decreases, the removal becomes easy.
Yes, sir.
It means atomic size increases and the enthalpy of ionization decreases down the group. Note down all
Yes,
this.
sir.
Note down all this. You may now note down all this.
Yes, sir. Yes, sir.
Now, along a period. Now I'm going a longer period. There is no regular trend. There is no regular trend. I'll not discuss why not regular trend. If I go from lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, then neon. If you go in this sequence, nuclear charge 3, 4, 5, 6, 7, 8, 9, and 10. Right?
Yes, sir.
If you just see the nuclear charge, we will say that nuclear charge is increasing. So enthalpy of ionization should increase. Yes or no?
Yes, sir.
But what happens here? Let us see. If you see the electronic configuration lithium, it is a 1s2 and 2s1. And for the beryllium, it is a 1s2 and 2s2. You can see two things here. Number one, it becomes completely filled. And number two, the nuclear charge increases. Both of these factors are responsible for high enthalpy of ionization. And that is why beryllium has a higher value as compared to lithium.
Yes, sir.
There are two factors which are responsible for the high enthalpy of ionization for the beryllium as compared to lithium. Am I clear?
Yes, sir.
Now, if we compare the boron here, the electronic configuration is a 1s2, 2s2, and 2p1, 2px1. You got it now? Now,
Yes,
out
sir.
of these two electronic configuration, can you tell me which is more stable?
Sir, beryllium.
Beryllium, completely filled, right? So even
Yes, sir.
though it has a higher nuclear charge, beryllium has a higher enthalpy of ionization as compared to boron,
Okay. Yes, sir.
right? The prime importance goes to the boron,
Yes,
to the
sir.
electronic configuration. Sorry, the prime importance goes to the electronic configuration.
Yes, sir.
Now we see the carbon here. Write the electronic configuration. Can you tell me electronic configuration? You tell me.
Sir,
I'll
one
write
is 2s2, 2p2.
2p2. I can say 2px1 and 2py1.
Yes, sir.
It is completely filled, half filled, or incompletely filled.
Sir, incompletely.
What about boron? Completely filled or incompletely filled?
Sir,
So
incompletely.
I can say boron and carbon both are incompletely filled.
Yes, sir.
So now we will see the electronic nuclear charge. More than nuclear charge, more the enthalpy of ionization. Am I clear?
Yes, sir.
Nitrogen. Write down the electronic configuration.
Now, sir, can you tell again why carbon has greater enthalpy than?
See, if you see the electronic configuration, both of these are incompletely filled. Yes or no?
Yes, sir. Yes, yes.
It means now the stability is not coming through the half filled or completely filled. Right? Both are equally
Yes, sir.
unstable from the electronic configuration point of view.
Yes, sir.
Now we have the nuclear charge that is the controlling factor now.
Okay.
Greater the nuclear charge, more the attraction and more the enthalpy of ionization.
Okay, sir.
Okay, what about nitrogen? Tell me the electronic configuration of nitrogen.
Sir, 1s2, 2s2, 2px1, 2py1, 2pz1.
What about the electronic configuration? Stable, unstable, half filled? What?
Sir, half filled.
It is a half filled, and it is more stable as compared to complete incompletely filled.
Yes, sir.
Number one, it become half filled, and number two, the nuclear charge also increases. So both of these factors are responsible for the higher nuclear charge, higher enthalpy of ionization as compared to carbon.
Yes, sir.
I hope it's very clear now.
Yes, sir.
What
Yes.
about oxygen? Right, the electronic configuration.
1s2, 2s2, 2px2, 2p by 2, 2p by 1, 2pz1.
Okay, so it is an incompletely filled. Can I say that?
Yes, sir. Yes.
And nitrogen is half filled, which is more stable,
Yes. So nitrogen.
and that is why the enthalpy of nitrogen will be greater as compared to the oxygen.
Yes, sir.
Any doubt till now?
No, sir.
No doubt. Okay.
No, sir.
Now come to the fluorine now. Atomic number 9.
Sir, 1s2, 2s2, 2px2, 2p by 2, 2pz1.
Okay. Now compare the electronic configuration of the nitrogen, oxygen, and the fluorine. Both are
So
incompletely filled.
both. Yes, sir.
If both are incompletely filled, then which other factor you will consider now?
Sir, the charge.
Nuclear charge. More than nuclear charge, more than enthalpy of ionization.
Yes, sir.
Right?
Yes, sir.
Next one. Helium.
The neon.
Yeah, neon.
Uh, 1s2, 2s2, 2px2, 2p by 2, 2pz2.
Okay. It's a completely filled.
Yes, sir.
Moreover, nuclear charge is also more.
Yes, sir.
And that is why the enthalpy of nitrogen, enthalpy of ionization for the neon is more than that of the fluorine.
Yes.
So you'll find some exception cases. Number one, in case of the beryllium. Number two, in case of the oxygen.
Yes, sir.
Right? That is how we can say that enthalpy of ionization along a period is not regular. It depends upon many
Yes, sir.
factors. It depends upon many factors, right?
Yes, sir.
Any doubt till now?
No, sir.
No. Second, next add on successive enthalpy of ionization. Next add on successive enthalpy of ionization. Successive means after loss of one electron, I am now removing the second electron or I am removing the third electron. This is called as a first enthalpy of ionization. Now the successive will be called as the second enthalpy of ionization and third enthalpy of ionization or fourth enthalpy of ionization. Successive enthalpy of ionization means the energy required to remove electron after removal of the first electron. When it becomes unipositive ion or dipositive ion, from the already ion, we are removing one more electron. So how much energy is required, that is called as a successive enthalpy of ionization.
Okay, sir. Also, this after the first process.
Yeah.
Okay.
Karma, now you have to compare the second enthalpy of nitrogen, enthalpy of ionization for the nitrogen, and second enthalpy ionization for the oxygen. Can you tell me which one is higher?
So how will we do this?
Okay. See, nitrogen, I have removed the first electron from it. It become N positive, where I have applied first enthalpy of ionization, right?
Yes, sir.
Now I'm going to eject out the second electron, and here I require second enthalpy of ionization, right?
Yes, sir.
And now the oxygen, delta IH1, it become now O positive, and now it become O2 positive, and here I require delta IH2. Am I
Yes,
clear?
sir.
I have to compare the enthalpy of ionization for the second of the nitrogen and second of the oxygen, which is a higher value,
Yes,
right?
sir.
Now, see the electronic configuration of nitrogen 1s2, 2s2, and 2p3, which is a half filled. Am I right?
Yes, sir.
And for the oxygen, it is a 1s2, 1s2, 2s2, and 2p4. It is incompletely filled, right?
Yes, sir.
So out of these two, which is more stable?
Sir, nitrogen.
Nitrogen is more stable, right? It means if I talk about the first enthalpy of ionization for the nitrogen is greater than the first enthalpy of ionization for the oxygen. Am I clear?
Okay, so more
Yeah.
energy is
It is for the
required
first.
to
It is for
build.
the first.
Oh,
But
okay.
for the second, my question was based upon the second one. After loss of one electron, I'm now getting this electronic configuration 1s2, 2s2, and 2p2.
Yes, sir.
And now this is becoming to 1s2, 2s2, 2p3 because I have removed one electron from here.
Yes, sir.
Now compare these two electronic configuration. Just a second, Karman.
Yes.
Am I clear?
Yes, sir.
So what you find here is the nitrogen has no oxygen has a half-filled electronic configuration, and nitrogen positive does not have half-filled. Now it is incompletely filled. It means oxygen one positive enthalpy of ionization means second enthalpy of ionization for the oxygen will be more than that of the nitrogen.
Okay.
Understood? Should I go ahead? Hello.
Hello.
Hello. Can you hear me?
Yes, sir. Yes. Hello.
Okay. Can you hear me?
Hello. Yes, sir.
Okay. So you got the answer out for the oxygen and nitrogen.
Yes, sir.
So now next topic. is electron gain enthalpy. Write on electron gain enthalpy. What is that? Write down. It is the amount of energy released when electron is added to an isolated gaseous atom.
Amount of energy released
An electron is added to when electron is added to an isolated gaseous atom. It means here we have an atom and now we are adding electron to it. It will become negatively charged. Some amount of energy is released minus X. Minus sign indicate it is exothermic. Right.
Yes, sir.
So that amount of energy that is released is called as a electron gain enthalpy. What is electron gain enthalpy? It is the amount of energy released when electron is added to an isolated gaseous atom.
Okay.
Understood? Now next write down factors affecting enthalpy of ionization.
So uh, energy is used to take out an electron, and energy is released when an electron is added.
Very good. Perfect conclusion.
Okay.
So whenever we add an electron to an atom, the energy is released.
Yes.
Now factors affecting enthalpy of ionization. Electron enthalpy, sorry.
Yes, sir.
It means greater the attraction for the electron, more the amount of energy released. Clear?
Yes,
So
sir.
write it down. More the attraction for the electron, more the energy released. So it depends upon number one, size of an atom. Depends upon size of atom. See, if the size of
Yes.
atom is more, what will happen? The number of shell will increase. Yes or no?
Yes.
If the number of shell increases, the screening effect will increase.
Yes, sir.
If the screening effect increases, the electron is nuclear charge is not reaching out effectively,
Yes,
and
sir.
the attraction for the incoming electron will decrease.
Yes, sir.
And that is why we say the electron gain enthalpy decreases with increasing atomic size. Electron gain
Okay.
enthalpy decreases as the atomic size increases.
Okay. Yes, sir.
Number two, it depends upon the nuclear charge. Greater the nuclear charge, more the attraction for the incoming electron
Yes, sir.
and more the energy released. Greater the nuclear charge, more the attraction for the electron, more the energy released.
Yes, sir.
Right. So, as you go down the group, right? As you go down the group, what happened to the atomic size?
Increases.
Increases. Attraction for electron will.
Decrease.
So, electron gain enthalpy becomes less negative.
Yes, sir.
Less negative means less amount of energy is released.
Okay.
Less negative means less amount of energy is released. Note it down.
Yes, sir.
Okay. But there are some exceptions. Two exceptions I will talk about down the group. If I talk about fluorine, chlorine, bromine, iodine, as you go down the group, atomic size
Increases.
increases. So electron gain enthalpy should decrease down the group. But it
Yes,
has
sir.
been found that the electron gain enthalpy of the chlorine is more negative, with more energy is released as compared to that of the fluorine. Am I clear?
Sir, can you repeat this?
I say normally what happens. First of all, I discuss normally what happened, but I'll talk about the exceptional case.
Yes, sir.
Normally, as you go down the group, this is a group number 17,
Yes, sir. Yes.
fluorine, chlorine, bromine, iodine. As you go down the group, atomic size, you tell me what
Atomic
happened?
size
Huh?
increases.
Increases. So the attraction will.
Decrease.
So electron enthalpy should become less negative as we go down the group.
Yes, sir. Yeah.
Means less amount of energy should be released. But
Yes.
in case of the
Yes.
chlorine and the fluorine, the reverse is observed. Means chlorine has a
Okay.
more negative electron enthalpy as compared to that of the fluorine.
Okay.
Understood? Yes or no?
Yes, sir. But why is this?
Now I'm coming to the reason for that. Why it is this? Have you noted down this thing? Now I'll come to the reasoning part of it.
Yes, sir.
The reason is fluorine atomic number 9. Can you write electronic configuration for nitrogen, for fluorine?
Yes, sir. Fluorine has 1s2, 2s2, 2p6,
2p5.
2p5.
Chlorine has atomic number 17. Chlorine has atomic
Yes, sir.
number 17. So can you tell me the electronic configuration now?
Yes, sir. Chlorine will have 3s2, neon 3s2,
Hmm.
3,
And p5.
3p5.
Okay. Do we have 2d subshell? Do we have 2d subshell?
No, sir.
No. It means in the second shell only. But do we have 3d subshell?
No.
Yes. Do we have d subshell? But it is empty in this case.
Okay.
Right. In case of the fluorine, we have only two shells are there. And in the second shell, there are only 8 electrons. Only maximum 8 can be filled, but 7 are already filled. 1, 2, 3, 4, 5, 6, and 7. And the 8 electron, if it is coming now, there will be inter-electronic repulsion because the fluorine is small in size. Second shell is small in size. So there is a inter-electronic repulsion between the incoming electron and the existing electrons. But in case of the chlorine, maximum 18 can be accommodated, out of which only 7 are there. It means there is no repulsion for the incoming electron. Electron can be easily added. And that is why chlorine releases more amount of energy as compared to fluorine. Should I repeat?
So can you, yes, sir, can you repeat
Okay,
that
okay.
why
Okay, now
fluorine?
come on, very simple thing. Very simple thing.
Yes,
Okay. I have my in somewhere in my neighborhood, right? There is a like one empty plot is there. Right? I mean, there's no any house built on it, but one room is all, or there is only one room there.
okay,
There, a family from some labor class lives over there,
okay,
right? It's a big plot, but there's only one room where some one labor class family lives there.
yes,
They are from Bihar somewhere, right? There only one room and there four members are there. There are just one room and there are four members living in one room, right? One, two,
yes,
three, four, right? If some guest come there, will the guest be happily accepted there to stay
no,
overnight?
sir,
To stay overnight?
no, sir,
No, exactly. It means by the evening, they will feel repulsion with the guest.
yes, sir,
Okay, now you can go. We have less space,
yes, sir,
right? Okay, now another house near just mine, another neighborhood. They have they have 9 rooms where people can live. They can sleep. They have bedroom type, we can say. Apart from the kitchen and washrooms and other things, right? But only again the same four members are living there,
yes, sir,
right? Four members in maximum they will occupy the 4 rooms,
yes, sir,
right? It means if their guests come in now, that can be easily accommodated.
Yes, sir.
Yes or no? It means in case of the fluorine, there is only two, it's a small size. Second shell is there, only two shells are there. In the second shell, maximum 8 can be accommodated, and 7 are already there. It
Okay.
means there will be some repulsion between the electron, incoming electron, and the existing electron.
Yes, sir.
I hope it's very clear. If
Sir, so
if attraction is
when
less, less amount of energy will be released.
yes, sir.
Okay. In case of the chlorine, we have now space for the 18. Space for 18
Yes,
electrons, but only 7 are filled. It means the next electron can be easily accommodated. They have a strong attraction for the incoming electron, so large amount of energy is released.
sir. How does chlorine have more space?
See, in the third shell, we have a D can accommodate 10 electrons, but that is empty space.
Sir, how is there 3D?
D is there, but it is not occupied by the electrons.
So we can also write in fluorine that.
We cannot write 2D. We don't have any 2D subshell. We don't write 2D. No? From the quantum number, we don't have 2D.
Okay.
Yeah, from the quantum number, if we calculate, we cannot have 2D subshell. But in the third
Okay.
shell, we can have 3D subshell,
Okay.
right? And that is why the electron enthalpy of the chlorine is more than that of the fluorine,
Okay.
right?
Yes, sir. Yes.
Right, Karman. So, Karman, tomorrow we'll class at 9 p.m. Will be okay with you?
Yes, sir. Yes.
9 p.m. Okay. And what about Monday? Do you have off on Monday or you have to go to school?
No, sir. There is school on Monday.
Is it compulsory?
Yes, sir. I have an exam on Monday.
Okay. And when do you come back from school on Monday?
Sir, 3 or 3:30.
3 or 3:30. Okay. Okay. So can we do the class on Monday? We'll see whether it can be done at 6 o'clock with you. Possible?
Sir, I will have to check. I mean, there can be a cricket coaching at
Okay.
that day
Okay. Okay. No problem. Then we will do it in our regular timing, evening 10 o'clock
on Monday.
on Monday. Hmm?
Okay.
That time is comfortable. There is no any restriction or no.
No, sir.
That is a perfect free time, right? But one thing,
Yes.
keep your energy up by that time,
Yes.
right? Otherwise, don't feel sleepy at that time. Otherwise, it'll the whole go waste.
Yes,
Yes,
sir.
sir. Okay, revise all these things, whatever I have taught you, right? And from your NCERT, solve all the questions. Now you can solve all the questions. NCERT back
Yes.
questions. Do you have an NCERT book with you?
Yes, sir.
Okay. Next time you ask me doubt from it.
Okay.
Right? I'll covering two more topics now. Only just two topics, small topics are left. We'll cover that. And then I'll discuss all the questions from the NCERT. Okay.
Okay.
Okay then. See you tomorrow evening 9.
Sir, yes, sir, can you explain this topic again tomorrow
Sure,
when we
sure,
start the class?
sure, sure, sure.
This
I will
one.
I will repeat the whole topic. Whatever you have doubts, I will cover it.
Yes, sir.
Have you noted all these things?
Yes, sir, I have.
Okay then. See you tomorrow evening 9 p.m.
Okay, sir.
Right? Okay then.
Okay.
Goodbye for now.